I'm going to get started on, and that is called the average rate of change. Rate of change and the slope of the secant line. All right, so first things first, let me remind you what a secant line is. If I have a circle and any line that goes through 2 points on the circle is defined as a secant line. Okay. If I have a curve, so let's say I have a parabola like this, any line that is designed to go through 2 points right here again is called a secant, Mr. T. It's called a secant line. On the other hand, if I have a line that's designed to touch the graph at exactly 1 point, like right here, that line is called a tangent line. Again, looking at the graph of a parabola, if I could find a graph that touches the line at exactly 1 point, again, we call that a tangent line. So when the topic up here says the average rate of change and the slope of the secant line, I'm making sure we understand what the secant line is. Later on, we're going to actually talk about the slope of the tangent line a little bit, but we start here. I'm waiting for you to finish drawing. Okay. All right. So to help us understand the topic that we're going to be discussing today, let's consider a situation. Consider the situation. All right, so the movement of a truck is defined by f of t is equals to 2t squared. Very simple formula. F of t is equals to 2t squared, where t is the time measured in seconds, while f of t is the distance measured in feet. Y'all have seen something like this before? I have an equation, f of t. If I want to tell you how far the truck has moved, you just got to tell me how much time. So if I tell you after 3 seconds, you can tell me the distance that the truck has traveled. You have seen a formula like this before? Yes? No?
Yes.
No?
Yeah.
Because we're about to use the formula right now. So, A, after after 3 seconds, how far away is the truck? Another way of asking that is, what distance has the truck traveled? Well, it's not exactly the same thing, but in our example it is, because it's always a positive function. Has the truck traveled? And does anybody know how I would figure out how far the truck is away after 3 seconds? Does anybody know?
Plug in 3 into t.
Yes, you find the function at the value of 3. So it's 2 times 3 squared. Of course, PEMDAS rules. 3 squared is 9. 9 times 2 is 18. So the truck would have traveled 18 feet in those 3 seconds. Questions there? Comments? Queries? Okay. Let's create a table of values for this data. For the movement of the truck. So you have your time, that's your x variable. And then you'll have your distance as in feet. Table of values. So after 0 time, by plugging 0, I'll have moved the distance of 0 feet. After 1 second, I'll have moved 2 feet. After 2 seconds, it's going to be 8 feet. After 3 seconds, it's going to be 18 feet. After 4 seconds, it's going to be 32 feet. And then after 5 seconds, it's going to be 50 feet. So what I did right here is, I had so much extra time at home. I went ahead and I plugged in all those values to create a sign chart for the movement of the truck. Questions there? All right, so everybody's done writing?
No, I'm not.
Okay.
No, not yet.
I'm good now.
Oh, okay. So the next part is going to take more than 5 minutes to do. So I'm just going to leave it for Thursday. I have this little table right here. What I want to do is I want to investigate the average speed speed at time equals 2. So let me ask you a question. Do you remember how to find the slope? Find the slope between time t equals 2 and t equals 5 seconds. If I ask you to find the slope, would you be able to do that for me right now from back in the day? And the people said, Yes, sir. Yes, sir. Of course I can find the slope. All you have to do is remember the formula. The slope is y2 minus y1 divided by x2 minus x1. Yes? And at t equals 2, that's going to be my first place. So at this point, oh, my bad, I'm actually off. At this point right here, when t is equals 2, I have that when the time is 2, the distance is 8. And then the second point at t equals 5, I have that when the time is 5, the distance is 50. Do I remember all of this? And so then that tells me then I have 50 minus 8 divided by 5 minus 2. And that gives me 42 over 3, which is equals to 14. Yes, is this the correct slope between 5 and time equals 2 and time equals 5?
Yes.
Yes.
Well, what does this 14 right here mean? What does this 14 right here mean in this situation? Well, I'll tell you what it means. If I go back and I look at my calculation, when I was finding the slope, y1 and y2 are distances, correct? And so therefore, when I subtract them, what I got was the change in the distance. And then I have that 5 seconds from 2 seconds to 5 seconds. Again, what happens right here was I was looking at the change in time. And so what that meant was that when I covered 42 feet, I covered that 42 feet in 3 seconds. So you see, this is what this right here means. If I consider the units that I am looking at, right? And so therefore, that means I traveled at a rate of 14 feet per second. Over that time period from 2 seconds in my journey up until 5 seconds into my journey, I covered 42 feet in that time. And I did it in 3 seconds. And so that means I traveled at an average speed of 14 feet per second. Oh, what did I just do? Oh, man. I traveled at an average speed of 14 feet per second. Questions there? I say all of this to simply state that when I ask you to find the slope, I am automatically or at the same time asking you to find the average speed. It's what we call a 2-for-1, right? You do one, you get the other one automatically. Any questions there?
Could you scroll up just a little bit? Yeah, right there is fine.
Questions there?
I got what I needed. Thank you.
Okay. So now what I would like for you to do for me right now is I want you to do the same thing I did, but I want you to do it for these two right here. So I want you to investigate the average speed at time 2. And so I want you to find the slope for time. I didn't write that. Actually, write the word slope. Find the slope from time equals 2 to 4. Find the slope from time equaling 2 to 3. And then the last one, find the slope from time equaling 2 to 2. All right, so that's 3 slopes. Okay, so let's roll. All right, so the first one right here, find the slope. That is going to be m is equals to, I cannot see the tip of my own self, 32 minus, minus 8 over 4 minus 2. That is minus 2 minus 6 is 24 over 2. That's 12. The second one, that is going to be plugging 3 squares 9 is 18 minus 8 over 3 minus 2. That is 10 over 1, 10 feet per second. And then the last one, the slope is going to be 8 minus 8 over 2 minus 2, and that's going to be 0 over 0, and that of course is undefined. Okay?
I have a question.
I'm listening.
So how you know what to input from the chart? See how you got 32 minus 8, 4 minus 2. Yeah, how you know?
So the formula is y2 minus y1 over x2 minus x1. And then I have to identify the points. So you see how it's saying it's going from t equals 2? So from the table, at t equals 2, you can see the coordinates at 2, 8. Right?
Okay.
And then the other one is going to be 4, 32. That's my y2, that's my y1. So I have 32 minus 8 in the top. And then the denominator is my x2 minus x1. That's my 4 minus 2. Okay?
Okay. Can you scroll back up a little bit?
Yeah, tell me when to stop.
Right there, right there. Okay, okay, I got it.
Okay. Cool. As they say in the business, cool beans. So, what has been happening up until this point, right, let's see, is that we were finding the average speed, right? But when we're looking at that average speed, something happened. If I am trying to find the average speed at the same point right here, this right here is not resulting in an, right? I got 12, I got 10, but now it's saying the average speed is undefined. But if you think for a second, you'd recognize that at the point 2, the vehicle had to have a speed, yes? And so the question is, how do we find that speed? Well, it turns out that the way we have to find that speed is what we've done before, is we have to take a limit to get to that answer right here. Okay, and so that takes us to the slope of the tangent line and the instantaneous. That's T-A-N-G-A-N. Speed. My speed. Oh. That's your rate of change. So what happened in the past, or the motivating theory behind all of this right here, is basically what was happening right here. They're trying to get an understanding of what's happening when time is equals to 2. We're trying to get an understanding of what happens when the time is equals to 2. And it so happens that I can figure out the average speed between 2 and 5. I can figure out the average speed between 2 and 4. I can figure out the average speed between 2 and 3. I can figure out the average speed between 2 and 2.5. I can figure out the average speed for lots of times right here, but I cannot figure out the average speed at exactly 2. And if you think about it for a second, the average speed at 2 would be the actual speed. If I tell you the average speed at time equals 2 to time is equals to 2 will be the actual speed of the vehicle. We call that the instantaneous speed because it's the speed at that instant. Can you see that right here? If I have the average speed between, if I have your average grade between, let's say you have 2 grades and the first grade is 90 and the second grade is 100, then the average is 95, right? But if I ask you for the average and the 2 grades are the same, i.e. the same time, so if you have a 90 on the first test and 90 on the second test, then the average will give you the actual grade, right? Right? And so there was this quest at that time to figure out, well, what is the average speed from time 2 to time 2? And someone figured out that when I'm trying to find the average speed, what I'm looking for is a slope. And so then what they did, or what they recognized, is that if I have a graph of the function, say f of t is equals to 2t squared, and if this right here is the point 2, if I draw what is called a tangent line at that point, well, the slope of that tangent will be exactly the actual speed of the vehicle at that time. Okay, and so what they figured out was a way to describe the speed, a way to describe that slope right here, but they didn't actually have a mathematical way of getting to that speed for a while until somebody figured it out. Because, you know, that somebody would not have been me because I was not around at that time. What they realized was that the slope of the tangent is equals to the limit as h goes to 0 of f of 2 plus h minus f of 2 divided by h, i.e. the difference quotient and actually that's why I've been practicing with that formula. We didn't create a difference quotient simply because it gives us 0 over 0. That's not why the difference quotient is created. It was created because it gives us a slope. That is actually why the difference quotient was created. And that's why we chose that formula in particular to practice with. It turns out that the difference quotient at the time 2, i.e. plugging in 2 right here, will give us the slope. Gives us the slope of the tangent line, which in turn is equal to the actual average rate of to the actual rate of change, to the actual ACTU, instantaneous rate of change. Questions there? Comments? Queries?
That's the formula for the slope of tangent, the tangent slope.
The slope of the tangent? Say again?
That's the slope formula, right?
The slope
No?
of the tangent uses this formula right here, the formula we've been using all this time, the difference quotient.
Okay.
That is why we've been practicing that formula. I didn't tell you up until now, but that's why we were practicing that formula. You don't find the slope of a tangent like how we did before. Y2 minus y1 over x2 minus x1. That's how you find the slope back in the day. But now, to find the slope of a tangent, this is the formula that you use to find that slope of a tangent. Okay? And the nice thing is that by me finding the slope of this tangent, I am automatically finding the speed of the vehicle. Questions there? Comments? So would you like to know what the speed of the vehicle is? At time equals 2? Oh, anyone still writing? Let me wait for a second. Would you like to know what the speed of the vehicle is at time equals 2?
Sure.
Someone said sure. First things first, I'll let you make a little guess. So between 2 and 5, it was 14. And between 2 and 4, it was 12. Between 2 and 3, it was 10. So what's going to be the speed between 2 and 2? The first one was 14. Then the next answer we got was 12. And the next answer we got was 10. What do you think is going to be the speed of the vehicle at 2 seconds into the journey?
Undetermined.
I just said we could find it. The way you find it is by simply working this out. Limit as h goes to 0, f of 2 plus h minus f of 2 over h. Step 1. I have to find f of 2 plus h. Oh, by the way, let me remind you, f of t is 2t squared. So f of 2 plus h is 2 times 2 plus h raised to the second power. And that's going to be 2 times 2 plus h times 2 plus h. I got to 4 this thing out. 2 times 2, 4. 2 times h, 2h. H times 2, 2h. H times h squared. I can group the middle terms together. And then I can distribute the 2. 8 plus 8h plus 2h. And that is the end of step number 1. Any questions there on step number 1? All right, so step number 2. I have to find f of 2, which is simply 2 times 2 squared. Sheesh, that's a lot of 2's. That works out to be 8. 2 squared is 4. 4 times 2 is 8. By the way, I was just, somebody on Facebook sent me one of those puzzlers where they give you the different shapes and you got to figure out what the value of each of the shape is so you can figure out the final answer. Oh my goodness. People got so many of those. Let's not go there. Step 3 is to subtract. So I go 8 plus 8h plus 2h squared minus 8. And then the 8's will cancel. And then step 4 is to divide by h. And so that will leave me with 2h plus 8. So therefore, I had to finish off the problem. I have to take the limit as h goes to 0. And so yes, you were thinking about the right answer, even though you didn't say it. The direct substitution, 2 times 0 plus 8 simplifies to 8 feet per second. And so this vehicle was traveling at 8 feet per second at time t equals 2. Questions there? Comments? Queries? Concerns? Questions there? Okay, so are we good? Can we move? Can I move forward then? Well, it was nice and all finding the speed at 2 seconds. So this right here is the speed, the actual speed to ease. The actual speed at time is equals to 2, right? But what happens if I want to find the speed at time is equals to 3, or time is equals to 4, or time is equals to 5, or time is equals to 100? If I wanted to find the speed at all of these times right here, it would make sense to first find the formula for the speed. And then once we have that formula, we can then plug in 3, we can plug in 4, we can plug in 5, we can plug in 100, yes? Haven't we done this before right here? If we are trying to find the formula for the speed, what we need to find is the derivative, the general form of the difference quotient. Oh, I'm missing my limit as h equals to 0. And once I find that derivative right there, that derivative will give me an equation. And once I have that equation, I can then find the speed at any time. I can plug in at time 0, I can plug in at time 500, I can plug in at time 3, and that will work out to give me my equation. Any questions there? Y'all okay out there, kind people?
Yes.
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 Well then, let me ask you to do that. For go ahead and find the derivative for this thing and put it in the box right here. So for f of t equals 2t squared, find the derivative using the 4-step process. Find f prime of t, which will be an equation for the speed. For the speed of the vehicle. Go ahead and try that for me, please, and thank you. Everyone knows what to do, right? Go ahead and give me a thumbs up. Go ahead and give me a thumbs up. So, following along with little old me. Oh no, say it ain't so. No, exactly. You leave x in the formula. You just leave x alone and work it out with the x in there. That's how you find the derivative. Let me see. I think I have an example. Find the derivative. Yeah. So see, I have find the derivative of this function, 3x squared minus 4x plus 2. Step 1 is you have to find f of x plus h. See how the x stays in the answer? And then when you work it out, you get this long right here at the end of step 1. And step 2, you don't do anything. Step 3, you subtract the two answers. Then step 4, you divide by h, and then you take the limit as h goes to 0. And then after all doing this right here, notice there's still an x in the answer. Or in this case, a letter t. And so what happens is when you're working the derivative, you always get an equation. The answer is an equation, or function rather. Okay, and then if I want to know the speed, when time is equals to 5, I'll just plug in 5 in, and that'll give me the speed when time is 5. So that's what I'm asking you to do for the equation 2t squared. Where did I go? Yeah, so that's what I'm asking you to do for the equation 2t squared.
Are we plugging the x plus h and the x into the 2t squared?
Yes, you are.
Okay.
Anyone else who's not sure what to do? Yes, Mrs. Lawrence, that answer is right. Clayton, f of x going, just, you want me to help you out? You can do this instead. F of x is equals to 2x squared. Does that help? Remember, t and x, and they're just variables. They're just names. It doesn't matter. All right? Does that help? And so I'm asking you to find f prime with x for f of x is equals to 2x squared. Normally it'll be 2x squared plus 5x minus 8. I'm just leaving this part off. It's a simple equation, just 2x squared. Okay? So, Clayton, yeah, technically the answer to your question is neither. Because 2t squared is just the definition of the function. 2x squared. Times. Anybody else stuck who needs some help? I got one right answer so far. I'll go on. Kamari, you gotta take the limit as h goes to 0 to finish it off. Miss Lee, you gotta take the limit as h goes to 0. Remember, it's the definition of the derivative is limit h goes to 0. So you're 90% of the way home. Mary, where you get the +4 from? That +4 should have canceled out. Yes, Miss Lee, that is correct. Happy birthday to you. Happy birthday to you. Happy birthday. Xavier, you got to limit as h goes to 0 to finish off. I'm not sure how you got that 8 though.
You said I have to find the limit, you said?
It's just like a difference quotient. The last step is take the limit as h goes to 0.
Oh.
Remember, it's just a general form of difference quotient. It is a difference quotient. We're just letting x be free to do its own thing. Anybody else has an answer for me? So go ahead and if you don't have an answer, put something in the box. If you've just been waiting me out, I don't know what to do. Go ahead and put something in there. Let's see where you stand. Let me show your hand. See where we stand. Some answers are coming in. Okay, Andrew. I see what you have, Earl. Jonathan, I see what you got. Okay, let's roll. I want to find the derivative of this function, f prime of x. The formula is the limit as h goes to 0 of f of x plus h minus f of x divided by h. In this example, f of x is equal to 2x squared. Yeah, that's right, Mrs. Finesse. And so, step number 1 is to find f of x plus h. And so that's going to be 2. I'm going to plug in x plus h right here. X plus h squared. That's 2 times x plus h times x plus h. That's going to be 2x squared plus xh plus xh plus h squared. That's going to be 2x squared plus 2xh. When I add these together, plus h squared. And then I distribute the 2. That is the end of step number 1. Step number 2, remember for the derivative, step number 2 is really easy because you don't have to do anything. F of x is simply 2x squared. That is it for step number 1. You just rewrite the equation exactly as is. Step number 3 is the subtraction step. And so I got to subtract the 2 answers. Well, the 2x here and the 2x here, when I'm subtracting, these two will cancel out. Right? For step number 3. Nothing else cancels out. And so that simply leaves me with 4xh plus 2h squared. Let me pause right there. Have I lost anybody? Any questions so far now that you see me working through it?
No, sir.
Step number 4 is to then divide by h. 4x, it's not an x, plus 2h squared divided by h. Cancel, cancel, cancel. That leaves me with 4x plus 2h. Yes? And of course, now that I've come to step number 4, I finish the problem off. I take the limit as h goes to 0 of 4x plus 2h. By direct substitution, I will have 4x plus 2 times 0. And that gives me an answer of 4x. F prime of x is equal to this. This derivative right here is a function or a formula for the speed of the truck. Can you see that right here? Well, not can you see, I'm telling you that's what it is. So remember earlier on when the speed was, at time 2, the speed was 8? Remember that? The 8 was 8 feet per second at time equals 2. If I take this function and I plug in 2, I get 4 times 2, I get the 8 feet per second that we got earlier on. If I want to know what the speed is at, say, 10 seconds into the game, f prime of 10, that's going to be 4 times 10, 40 feet, 40 feet per second. And so on, and so on, and so on, and so on. Any questions there? Comments? Queries? Concerns? Okay. Let's try one more question. And then we can send you guys on your way, I guess. So, oh, but if I do that, are there any questions there again? If I do that, any questions there again? Okay. Question.
I have a question, but it's not about like how to do it. It's like how to write it on the test.
Mm-hmm.
So like, I know when I do it, I group like step 1 and step 2 together. Do I have to like write out each step that I'm doing?
No, I'll figure it out.
Okay.
Okay. So the position of a delivery truck is given by the formula f of x is equals to 2x squared minus 10x plus 4, where f of x is measured in feet. How many feet does feet have? And x is measured in seconds. So, 1, find an expression for the speed of the truck. That first part right here, asking us to find an expression for the speed of the truck. This is asking us to find the derivative of the function. Because remember, in like the previous example, the derivative is that function, that expression. Once I know what it is, I just got to plug in the right number and that'll give me the speed. Yes? Once you know that right here, find the speed at time x is equals to 4, x is equals to 8, and x is equals to 10. Go ahead and do that for me, please. Find the equation for the derivative and plug it in the box and tell me what it is. I'll give you about 10 minutes to get it done, or 10 minutes. So go ahead, start working on that. Anybody not sure what we're doing? Control. Yeah, but that's why you gotta practice step 1 the most. This is the hardest step. But because the hardest step is the most important step, you gotta find a way to get it right. Anybody else having troubles with step number 1?
Yeah.
Yeah.
Okay, fine. I'll help you out. I'll help you out one more time. One more time. One more time. All right. First things first, always start by writing out the formula. I am trying to find the derivative, so I write limit as h goes to 0 of f of x plus h minus f of x divided by h. Okay? Remind yourself of what you got to do right here. First things first, step 1. And step 2. Remind yourself this is the easy step because you don't have to do anything. Okay? Subtract right here, that's step 3. Sub SUB. Okay? Then this is step 4 right here. All right, so then I always like to remind myself of what the function is. The function is f of x is equal to, I can't see, 2x squared minus 10x plus 4. I always like to remind myself because it makes it easier when I'm plugging in the x plus h to see what I'm plugging it into. So, step 1. F of x plus h. So, everywhere you see an x, it becomes x plus h. So 2 times x becomes 2 times x plus h minus 10 times x plus h plus 4. Okay? Now I gotta work this out, but we worked this out before. It becomes x squared plus 2xh plus h squared. I leave everything else the same. And let me pause right here. Any questions? Comments? Queries? Concerns?
Are my answers right?
Oh, Miss Lawrence, they look like they're right. Yeah, I believe so. I don't have, oh man. Went all the way to the top. Oh. All right, so now I have this right here. I distribute the 2x squared plus 4xh plus 2h squared minus 10x minus 10h plus 4. And that is the end of step number 1. So now that I have this right here, that is the end of step number 1. Step number 2, the easy step, is you do nothing. F of x is equals to 2x squared minus 10x plus 4. Step number 3 is to subtract. And so you would have like terms canceling out. You'll always have the same exact term in both pieces. And I always remind students that when you completed step 3, you should have something that only has h's in there. That's part of the reason what helps this next step, because I got to divide by h. Yes? Don't forget f. And so then step 4, divide by h, 2h squared minus 10h divided by h. Cancel, 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 cancel. And that leaves me with this right here. Of course, I am not done at this step right here. Miss Lee, see if you can figure out what happened to the negative 10. You should have had negative 10 there, Miss Lee. Now that I have this right here, I can then go ahead and take my limit as h goes to 0 of the expression. By direct substitution, that leaves me 4x minus 10, and that is my derivative. Hard work and sacrifice. Any questions there? Comments?
Yes, can you go up a little?
10 minutes start.
You can stop right there.
Anybody else?
So for every X, you just put X plus H.
Exactly.
Okay, I gotta leave that in my head.
You gotta write that down in your notes.
It's in my notes. It's in my notes, but I'm having a hard time comprehending that.
Oh, okay. I was actually saying I meant write the words down. Write the instructions down so you don't forget those instructions. All right, I think you got it right now. So now I have that done. I can now, so this right here is the expression for the speed. For the speed. So now I can find the speed when they were talking about. They wanted the speed at 4, 8, and 10 seconds. And so I simply find f prime at 4. I believe that is 6. F prime at 10. Oh, I missed 8, sorry. So that's 4 times 8 minus 10. 4 times 8 is 32 minus 2 is 22. And then f prime at 10. 4 times 10 minus 10, that's 30. And those will be the various speeds of the truck at the various times.
Before you move on, I'm trying to figure out why you canceled out the 4.
Cancel out the 4 right here.
Yeah.
4 right here and this 4 right here.
Wait, show me again. What did you say?
So what happens is this, let me erase. Go away, go away. This right here that I am now circling. Oh, the right term. This what I'm circling right here. That is the end of step 1. Okay?
Okay.
Simply put, anything that does not have an H will get canceled out.
Oh, okay.
Okay? 2x right here, or should just be 2x squared, sorry. And this 2x squared right here will cancel out. The negative 10x and the negative 10x will cancel out. The 4 and the 4 will cancel out. Okay?
Well, I didn't see that second 4 right there. That's why.
All right, I got one more question for you guys. One more question. When will the truck be stationary? I have the equation for the truck, and therefore I can ask you this question. When will the truck be stationary? Does anybody think they know how to solve this problem right here? I'll take that as a yes. So then somebody tell me how I find this answer right here.
Well, we said it's 0.
So because it's stationary, it means the speed is 0. Right? And so we take the equation that gives us the speed, 4x minus 10, and we set that equal to 0, and we solve for x. Okay? So it's going to add 10 to both sides. So 4x is equal to 10 divided by 4. X is equal to 10 over 4, which is 5 over 2, which is 2.5 seconds. At 2.5 seconds into this journey, the truck will not be moving.